The idea today was to introduce you to our recent paper on increasing intensity of heat waves and the crucial role of metrics for geophysical research letters that was published in July 2023. The authors are myself and Daniela de Muysen, who is affiliated at both ETH Zurich and at the University of Lausanne. So the layout of the paper is quite simple. We have three main goals. One, to contribute to a more unified use of heat wave magnitude or intensity indices. We want to perform an evaluation of erratified land dataset across other observational datasets in terms of interannal variability of seasonal maximum temperatures. And also we will have a look at the changes in the most extreme heat waves at different locations over the globe for the entire period 1950 to 2021. Before diving into the results and the method section, I start just giving a brief introduction of the data that we use. Basically, all the paper is based on daily maximum 2-meter temperatures that are derived from 3 datasets. Our main reference is erratified land. So it's a kind of a product derived from ERA5 reanalysis data with by running a more sophisticated land scheme, a land model by Munoz and Sabater et al. 2021. The input data that we use have a special horizontal resolution of 0.25 degrees over longitude and latitudes. Their initial temporal resolution that we use to derive maximum daily temperatures is an hourly resolution, and the data are available for the period 1950 to 2021. Then for comparison and evaluation of this dataset in terms of daily maximum temperatures, we also use the Berkeley Earth observational dataset. There is a coarser resolution of 1 degree. The data are provided directly at daily output with daily outputs. And again, it is available for the entire period 1950 to 2021. Finally, we use the Japanese reanalysis data, JRA55. Again, the resolution that we use, the data that we use have a spatial resolution. They are regraded data from the original files at the spatial resolution of 1.25 degrees over longitudes and latitudes. The initial temporal resolution of the data is 6 hours, and this time the data start in 1958. For our analysis, for simplify things, we just cut out leap days, and we can focus our attention on all the globe, but starting at minus 80 degrees north to 80 degrees north. Okay, a small introduction on the definition of heat waves that we use in our study. We use a rather classical definition. We define heat waves as at least 3 consecutive days with temperatures above a given threshold. And this threshold, for this, we define a threshold for each day of a year, D, as the 19th percentile of the set of data, AD in this case, that is given by the union of all the temperatures in a window of minus 15 to 15 days around D, so the selected day of the year, and for all the years of the period 1961 to 1990 that we consider in this case as the reference. So basically, for each year of the period 1961 to 1990, for each day of the year, we have a different threshold. So we have a kind of running threshold that is given by the 19th percentile of like 31 days repeated 30 times. We conduct the analysis for all seasons separately, and then we, in order not to consider events, count them twice, So basically, we consider in large seasons starting, for example, for June, July, August, we consider the season starting in May and ending in September in order to tackle or to track events that happen across 2 different seasons, but then also not to count events twice. We assign events to a specific season depending on these like overlapping events, depending how many days they have, for example, over March or over April. Let me know if this is not clear. Maybe we can discuss in the end. But given this introduction on the definition of heat wave, the paper basically we start by comparing, or we compare 4 main indices of heat waves. We take 3 metrics for assessing the intensity or magnitude of heat waves. We take 3 metrics that are used in the work of Perkins and Lewis 2020 that are defined as the average intensity, so that is basically the mean of the absolute values of temperatures during the days characterized by heat waves. Then we have the average anomalies that are simply the average, in this case, of the anomalies with respect to the threshold TR90 that we have seen before, always again during all the days that are characterized by a heat wave. And then the other metric from Perkins and Lewis is this heat count that is simply, instead of the mean of the anomalies, is simply the sum of the anomalies over, again, the days that are heat waves. One point that I want to highlight here, in the paper, our main results are based on, basically, these are all metrics that are defined by considering all the sums or the means over all heat wave days of a season together. So not single events. This is somehow a bit different than the other metrics that we consider from the paper of Russo et al. 2015, where that is defined as HWMID. And this is basically the sum over, for a single event in this case, over all the days of a heat wave, of this this term here that is defined as the magnitude daily, is a function of temperature and is defined as the standardized values of the anomalies with respect to the 25th percentile of the interannual variability of seasonal maximum temperatures over the reference period 1961 to 1990, divided by the interquartile range of the seasonal maxima of daily maximum temperature. Is either this value, the standardized value, when the temperature is very high, so it's higher than the 25th percentile of the maxima, the seasonal maxima of temperatures over the reference period, or we consider it 0. So this metric is designed to really target very pronounced extremes or very pronounced heat waves with a very pronounced intensity. As I said before, the peculiarity of this is that instead of applying this to all the heat wave of a season, here we do the sum of this term and of the daily magnitude only over the days of an event. But we will take care in the paper we have taken care to also apply this similarly to the other metrics to all the heat wave of a season, and we have seen that the results basically do not change. So what is the peculiarity of these 4 metrics? Basically, we see that the first 2 are basically based on an average, so over a given period. On the other hand, the other 2 metrics, the heat count and the HWMID, are basically simply a sum. So our question was, do we see, I mean, we have seen in literature that the two kind of families, this kind of families of metrics, so either based on an average or on cumulative values, are used quite indiscriminately. Like, there is not much attention on whether we should use, whether the use of one of these two families of metric makes any difference in the results. So we basically apply the comparison, and so I try to determine whether we should be more careful in the selection of the metric that we use for heat waves. And here, before going to the results of this comparison, I just showed the results of a comparison of the heat wave, sorry, of the different data sets. As I said before, the ERA5 land against Berkeley Earth for the entire period 1950 to 2021 on the left-hand side, and ERA5 land versus JRA 55 for 1958 to 2021 on the right-hand side. We applied the comparison for all the season. What I show here is the Spearman rank correlation of seasonal maxima of daily maximum temperatures over the considered period. And what we saw is that in general, we have a good agreement between ERA5 land and the other data sets only for selected areas of the higher latitudes. That's somehow expected because most of the observations that we have for the entire considered period is, so the areas with higher number of observations is mainly North America, Europe, and part of Asia and the former Soviet Union. And on the other hand, ERA5 land, we know that is derived from a preliminary version of the ERA5 back extension that is known to have issues in tropical areas like Central Asia, in particular over the 50s. So this was something that we did, and we took this into account in our next analysis. But overall, over the Northern Hemisphere, basically, ERA5 is in good agreement with the other datasets, and we think that it is reliable to conduct any kind of analysis in terms of heat waves. Here I show the results instead of the comparison of JJA, June, July, August, maximum heat wave intensity for the period 1950 to 2021 that we obtained for the four previously introduced metrics. In the upper row, I show the results that we obtained for the cumulative base indices. So the heat wave magnitude index daily of Russo et al. 2015 on the left in this case, and the heat count. So the maps show the maximum intensity that is, according to ERA5 land, for the entire period 1950 to 2021 in JJA. As you can see, there is quite a good agreement between the two different metrics, even though one is considering only single events, and the other one is considering all the events for each season. The dashed lines here, the black dashed lines represent areas where the correlation that we calculated before, the Spearman rank correlation of interannual values of the assessment of the correlation in terms of interannual variability of daily maximum temperatures, of seasonal maximum of daily maximum temperatures, sorry, is below 0.5. So all the dashed lines are areas where there is not good agreement between ERA5 and the other two datasets. But then what happens when we calculate the same metric also for the average base, when we calculate the maximum intensity for the average base metrics, actually we see a quite different picture. Of course, for the metric that are based on simply the mean of the absolute values, basically it's hard to conduct a proper comparison because basically we see the difference derived by differences in the climatological values of temperatures. But what is interesting here is that when comparing heat cam and HAVA, that are basically the same thing, one that is given by simply making a sum of the anomalies, but on the other hand also averaging the same anomalies, we see that there are quite some differences in between the two metrics. In particular, while we see here an event or a very pronounced peak in heatwave intensity over Western Russia that is reconductible to the event of 2010, the dramatic event that hit Russia in 2010, this disappears when averaging, so this signal is somehow lost. And when we look also at the years when the most extreme, the most intense event occurred between the two different family of metrics, in all the period 1950 to 2021, we see again that we have quite a good match between these two sum-based, cumulative-based metrics, with the world that is mainly covered in more towards reddish color. So we have the maxima are closer to the present as expected. But when we use the average-based metrics, this signal is somehow lost. So we see that actually, whether we select one or the two family of metrics actually make as an effect on the results of any kind of trend that we want to calculate in terms of heatwave intensity. And we have to be careful, we have to pay attention on the type of metric that we apply in our studies. And given that, in general, we suggest to use, as already suggested by Russo et al. 2015, that the intensity of heat waves through average values should not, or metrics for assessing the intensity of heat waves based on cumulative values of the anomalies should be a better option compared to the metrics based on average values, because the latter, so the ones relying on average values, do not allow for an unequivocal comparison of the magnitude of events with different length. So to better understand this, I report here an event. We consider two different heat waves, HW1, lasting 3 days and with anomalies over the 3 days always of 3 Kelvin. And then we have heat wave 2, so HW2, with heat waves lasting 4 days with anomalies of temperatures exceeding the threshold by 3 Kelvin in each of the first 3 days, as for HW1. But then in day 4, we have an anomalies of just only 2 Kelvin. So if we want to detect which event is more intense, and we use an average metric, a metric based on the average, we will counterintuitively see that HW1 will be more intense than HW2. And that is something that we should really take into account. And as I said, in our paper, we suggest that cumulative metrics for the assessment of heatwave intensity should be a more reliable choice. Finally, we just have a look at trends or at differences between the period 1950, 1985, and 1986 to 2021 in terms of very extreme heatwave intensity. So we basically select in each period only for different regions that I will show in the next plot, all the heat waves point by point for which the HWMID exceed the 99.9th percentile of the period 1950 to 1985. So basically, for these 3 regions where we saw that RFI is kind of more reliable in terms of daily maximum temperatures, we basically compare all the events that exceed this threshold, so that exceed basically the maximum value of extreme heat waves or most intense heat waves for the period 1950 to 1985 in each single region. Basically, we see in the weather what was almost impossible for the given areas in the period 1950 to 1985 has become more likely in present days? And the answer is absolutely yes, but in different ways across regions. So the blue bars here in these histograms are the number of events exceeding this 99.9 threshold in HWMID in each of the regions from left to right: Central North America, Northern Asia in yellow here in this map, and Europe. As you can see, overall, here I consider just two seasons, JJA and DJF. What we see is that normally what was almost impossible, very unlikely, has become more likely. We see in purple that the bars exceed normally the blue bars. So where in these histograms I have on the x-axis my metric for heat wave intensity, so HWMID, and then I have in each case on the y-axis the number of heat waves exceeding my threshold. As you can see, generally we see more purple bars, or more pronounced number of events for each of the bars that we see here. We see also the purple bars having more extreme intensity. So we have more events, not only more events, but also more extreme. But what is also interesting, that I think it also fits with what we know from other literature, is that Europe actually seems to be the region that has been most highly affected by changes in heat waves due to possibly due to global warming, not only in summer, but also in winter, actually. And these changes we see that for Europe, what we have like 10 times more events, more very extreme events compared to the previous period, so 1950 to 1985. And the extreme have become 3 times more intense during the recent years. And with this, yeah, I conclude basically with this slide. Again, we suggest to prefer cumulative metric for assessing the intensity of heat wave. We have seen that the two families of metrics might lead to different results. So we must be careful when we use, in particular, average intensity for determining any trend on heat waves intensity. We have seen that actually ERA5 land is only, we think, reliable only over selected regions of the Northern Hemisphere. And then, as I said in my last slide, we have seen these nice or scary trends in heat wave intensity that are partly known in recent literature. Yeah, and with this, thank you very much for your attention.